Hello and welcome back. I'm sure you would have enjoyed that stretch break and you got everything flowing in your body and got the energy back to learn and finish out what's unfold with the rest of the day. I just went to IDE and I went to file. I started a new file by going to file new STM32 because I connected the hardware on my table and it's in my desk and it's connected to my computer. So I'm going to select board selector. As you know which board you're going to use, it's Nucleo F411. So I can click the drop down box and use the Nucleo F411RE and then hit select and go next. And you need to give it a name. So I'm going to give it as a name as exception demo. And then choose targeted project type as empty and then finish. This will fetch to get the value and add all the files to it and you will learn from the files. So once it hits there, it's still loading and connecting. Just bear with me one sec. I'll show you. Okay, so the first thing, I'm going to close all of this so you won't get interrupted. I'm going to exception demo. I'm going to the source code. I'm going to double click on the source code. As you know, this is for your reference. You got to say what it is and what program and who has written, just for reference. So I will delete all the information in there and I will start to show this exception handling. stdio.h. Okay, so now we're going to use the two registers that we talked about, the ISPR and the ISER. So to do that, I'm going to define the IRQ first. Hash define user2. We are going to use user2 IRQ number because we're going to use this often, so you need to define outside as a global so you can use it inside the main program. So if you knew the IRQ number, then you want to enable that and set that inside the main program. So inside main, you got to use those two registers, uint 32 underscore t, and I'm going to declare with two peripherals. Okay, before going there, I need to build the project so I can set up the debug options. So I'm going to build and generate elf file and then set my debug, and then I'll go to show you how to write. It's checking 19%, checking still 20. Okay, 0 errors, 0 warnings, that's good. Then I'm going to set the debug as, go to debug configurations, and then you need to select that and choose the project that you're going to use. Right click, okay. Right click, debug as, debug configuration, and you got to choose exception debug, and it's connected to exception debug, and make sure in the debugger you enable the st link and the enable, then click apply and then debug. This will change from C perspective to debug mode, which is what we want to learn about this program, and also to view all the registers. So we are in the debug mode. Just one sec. Yeah, switch. So these are all the registers, and to see the registers you need to go window, window, show view, and we're going to go to SFRs this time. SFRs. So these are all the exception handler registers that's by default given by Cortex M4, by STM32. These are all the outside peripherals. That's a third-party vendor. That's the one we are using. The USART files will be through here. So we are after USART2. So enable that USART2, and that's the USART2. And this is what we are going to learn about today, and how you're going to interface that to NVIC, and how the stack pointer sits in the NVIC. So that's the project. So we're going to use ISER1 and ISPR1. So we need these two addresses. So let's go into the program. I'll show you quickly. We need to copy ISPR1, ISPR1. So I'm going to copy that and create a pointer variable first, and then typecast this int 32_t, and going to link that to the address. Two 204 is the address, and then finish with the comma, and then copy this, and we need the second register. So I'll just copy this. We need ISER1. We need this one because our USART IRQ is 38, so we need to use this address for the ISER1 and the register. So now we got to set both the registers. So to do that, I'm going to copy that, copy, to set the ISPR1 you can just simply R that with R, and then you can set that with USART2. This USART2, you can just set this USART2 NO with the modulus to enable that bit to get to that bit being all $32. So that's 32. And then likewise we need to set the ISER1. So I just copy this, and then I'll change this name ISER1, ISPR1. So we're going to set that as well. So now that's done. So now in ISER1, if you go, that's 31. So you need to go 32, 33, 34, 35, 36, 37, 38. 32, 33, 34, 35. So you get to enable this 38th bit. I'm going to save and run the project, build the project. So I'm going to show you the stack register. So now we need to run the USART IRQ interrupt. So for that you need to go to your startup file here, and from the startup file you need to get the vector table address and the exception USART2 exception. So come here, these are all the vector table with the names, and you go to USART2 IRQ handler. We're going to write a function. So we're going to manually trigger the program to change the location. So we're going to write a program. Void I'm just going to say print f, and just saying in USART2 okay, and to save and set a breakpoint in there so we can check. I'm going to terminate and relaunch, and I'll show you the stack pointer. So we introduce the exception here, and we introduce the exception here. So the current program runs in the thread mode. So as soon as it fetches to this function, it will stop that and it will go to handler mode. So what happens in handler mode? Whatever in the main stack pointer, that value will be in the stack pointer. So that's what the exception handler is. Prior to this, the main program will have both the MSP and the PSP, but now it only concentrates on the MSP. Set debug as configuration. Yeah, exception debug. So as I said, I'm going to show you now. We are inside the exception handler. So both the exception, the stack pointer and the main stack pointer will be the same value. So if you come here to the window show view, and this is still waiting 7989. Okay, switch. Yes, it's switched. And if you go to registers, the general registers, if you want, I'll show you before and after. So this is the general register now. Okay. So these are all the general registers. Now the stack pointer is reading 2001 FFF0. That's what the MSP is, MSP 2001 FFF0. So as soon as I hit the resume button, it will start to run, and you will see the value of the stack pointer and the MSP will be introduced to a new. So see, the stack pointer now is FFC8, and if you go to the MSP, it will be FFC8. So it works. So we manually introduce the exception, and the stack pointer being in the handler mode, it knows where the exception is and it agrees to the stack pointer. That's where the exception is, and that's what I'm working on. So this is what I wanted to show you today. So we learned about manually setting an exception and make the program to halt the thread mode and go to exception, and show the stack pointer where you are working and where that program is working. Okay. So now we're going to learn about the interrupt priority and configuration. What is a priority? Priority is nothing but uh, it is a term where you can categorize the severity of any call. So priority means urgency. So the lower the value, the higher the priority is. So that's what a priority. What is its priority value? Depends on the number of whether the internal priority or the external priority that's caused by the processor itself or from the peripheral. Everything will get its priority value, and by default reset is the top priority, and it will work on that. And you're going to see about different programmable priority levels. You're going to see about explore priority registers for interrupts and for system exceptions. And you're going to see what is preempt priority and sub priority. What is a priority? As I said, priority means urgency, very next one in line to queue to be executed. Um, Priority value is a measure of urgency, so it depends on the priority, everything gets a value. In this example, before NVIC gets to it, there is two priorities coming its way. One is from the timer and one is from the ADC. According to STM32, the priority level of a timer is valued 4 and priority of the ADC is valued 5. So the lower the value, the higher the priority. So therefore, the timer will get into the NVIC first, and it sends to the processor core, and it will work on this interrupt priority. This is what explained in these two. If both interrupts hits the NVIC at the same time, then the NVIC timer interrupt first, then the executed by the processor. And this is the different priority levels are also called priority levels. Values can be also called as levels. The number of levels depends on the manufacturer. So the Texas Instruments will have different levels. STM32 will have different levels. The one we are learning has 16 different priority levels. Priority value depends on the urgency of that value. So priority interrupt register from PRI 0 to 59, and everything is 8 bits. This is the different priority levels. This is the interrupt priority register implementation comparing with a vendor X to an vendor Y. Vendor X is something different, maybe a Texas Instrument or some other company or vendor, compared to the one that we are learning. STM32 got 16 priority levels. So I just want to show you how the difference. In this vendor X, only 3 bits are implemented, whereas in this vector implementation that we are learning, 4 bits are implemented in there, bit 4 to bit 7. And this is the priority register for system. If you go to tune into the system control block, which I showed you earlier, you got the system handler priority, system handler priority register 2 and register 3, and there is a system control and state register. So these are the priority registers that you can use to control that. Those three: SHPR1, SHPR2, SHPR3. Priority register 1, priority register 2, priority register 3. Then when you talk about priority, there is two different subtypes, if you like. One is preempt priority and sub priority. What is a preempt priority? When the processor is running in its interrupt handler and another interrupt appears in the queue or next in the line, then the preempt priority values will be compared to the previous interrupt and takes the higher chance from the priority value which allowed to run. So what preempt is, if the program works on some interrupt or exception, then another interrupt comes through its way, then it calculates a priority value and depends on the processor priority value. Say for example, we saw in the previous example, if it's timer or from ADC. So suppose if it works on the ADC, if the timer interrupt comes through, then it stops the ADC exception and goes to the timer, and it works on the timer. So that's the preempt. Finish that and then go to the next. And then what is sub priority? When both the interrupts are checked to resolve the conflict of both at the same time, then in those two, then again it checks the value of the level. So if the two interrupts comes with the preempt priority, then it's subdivided into a sub priority. In that case, interrupt with the lowest numbers will be allowed first. So that's the difference between preempt priority and sub priority. Now we're going to see about the exception in two different sequences, the entry sequence and the exit sequence. In the entry sequence, the pending is set, bit is set first, and then the stacking and the vector fetch the address, and the stacking. Stacking is nothing but adding on addresses to store the value through push instruction. Remember push instruction? So that's what stacking is. Stacking is loading the memory values to the addresses. Entry into the handler mode. So initially the program will be in thread mode. As soon as an exception comes, it immediately switches to handler mode and it sets itself active, clearing the pending state, and now the process mode changed to handler mode. The exception exit sequence in ARM M3 M4 is when it finishes that, it unstacks the value through pop instructions. Pop is retrieving the data out, and it returns with a special function register called exc_return. When exc_return is generated during the exception, it's stored in initially first in the link register, in the LR register, and when the LR register sends the message to the exc_return, and that sends to program counter. In every trigger it happens as the exception return, and that's how return to the program counter. So this is a picture to illustrate that. Again, thank you to Pantech Pro Labs for using the picture. Initially the processor mode will be in thread mode, so the process stack also will be in thread mode, and as soon as it starts, it will start to stack all the memory allocations through push instructions. And as soon as an interrupt starts, it goes to the interrupt service routine, and immediately the processor will change to main stack and change the mode to handler mode. And this is the mode where it works on the exception, and once that's finished, it start to unstack, meaning retrieving all the data out through pop instructions. And once the unstacking is finished, then again the processor stack will go back to thread mode, and the exc_return will be returned to the link register, and the link register will write that to program counter, and this is how the programmer will know now the exception is handled and back to normal function, and that's how it works as normal. So this is the two different types of sequences: exception entry and exception exit. Both works on stacking and unstacking. Stacking is push instructions, unstacking is pop instructions. In exception return, during an exception handler entry, the value of the return address PC is not stored in LR, done during calling a C function. Instead, the exception mechanism stores the value of exc_return in load register. So in the return stack, if it is return 1, it will return to process stack pointer. If it is return 0, then it will return to main stack pointer. In the return mode, if it is 1, it will return to thread mode. If it is 0, then it will go back to handler mode. So what are all these sections and the areas we learned today? We learned what an exception is and where it is used, and its types, what are all the different types, and what are the various exceptions and what are the various interrupts, and its exception states. Today it's about exception handling, so we learned about exception states and different types of exception handlers, and the NVIC, the nested vector interrupt controller, and its registers. And then we went through code to see how you can manually set an exception and ask the program to handle that exception. So you learned that through an exercise demo, and also you learned about the different priority values and also two types of sequences, the entry and the exit. As I said earlier, you also have to develop your mindset on the side as well with the skill set. Today's lesson with the mindset is about belief in you. The more you believe in you, the more success it will come. So start to believe in you. You can start to imagine that anything is possible. Through a lot of practice, lot of training, anything can be possible. First have that belief in you. So once you have that belief, then the success points will start to happen, then you will act on it, and eventually you will end up being successful. So first believe in yourself. and have the faith like you can, if you believe, you can literally move the mountains. That's the faith. In other words, if you have the strong faith that you're going to be success, no matter what other people tell you or no matter what other distractions come to you, you will just push that, kick that away, and you will stay focused and believe in success. So that's what it is. If there is a will, definitely there will be a way. So if you believe that you're going to buy a Mercedes car and you will act towards that and get into the goal of buying that Mercedes car or BMW car, so you have to think first and you have to believe in yourself first, and the success comes in. So don't ever believe in your doubts. Don't listen to your inner self, and don't ever believe in your doubts, and don't doubt your belief. So once you start to believe, don't doubt on it. And please start with the involvement as well. Write down your top 10 goals, write down top 10 ideas to achieve the goals. At least spend 30 minutes to do your exercise and workout. At least go for a walk and do 10,000 steps. That will get you 2 points here. And do at least spend 15 minutes to meditate or pray, and do spend another 10 minutes to visualize actually you are achieving that goals. And also spend another 10 minutes to plan for your day, for tomorrow's activities or the following week. And also, being a beginner, please spend 2 hours in learning and also take notes. That gives 2 points. Please be honest, and the end goal everyone has to target is 10 out of 10. And please post all your achievements in the group so others will get to learn about your involvement and your status, and they will get motivated. So we are going to help each other trying to learn. So that's how it's going to work, and that's how it should work. And there is combo internship coming up your way. I don't want to cram a lot of information in one single course, so I divide it into three as beginner, intermediate, and advanced. To get the full experience to learn about Cortex M4 series, please invest on buying all the three. And I'm sure at the end of the 30-day period, you will be in a better position and you can tackle anything that Cortex M4 throws at you. And you can write your own project, you can write your own coding. And also please stay tuned with us. There is internship bundle coming up and it's in process. You will be the first person to know, and you would be able to learn all of that, and that is worth a lot. So the self investment, again, it's a major investment. The more you self invest on you, the more you upskill you, the more you are irreplaceable in the industry. So that's why you have to learn all of that, and please stick by us and we will help you to get you there. And once again, I take this time to generously thank you for your patience, for sticking by with me and learning through all these sessions. And go and enjoy that lovely break from that screen. You deserve that, and you go and enjoy. This is Arul Anbukarsu. I'm signing off from A to Digi. Huru for now, and I wish you a lovely, lovely day, whatever activities you do. Please take care and take it easy, and I'll see you in the next session, and have fun. Please go back and revise if you haven't, and please revise all the concepts and get yourself familiar. And also contact Pantex Solutions to acquire for all the hardware. They would be able to help you to get all the hardware that you are needed. So once again, I thank you so much for your patience, and go and have a lovely day and a fruitful day. I'll catch you in the next session. Thank you. Take care. Catch you later. Bye now.